All right, 3.5, derivatives of trig functions. So what we're going to do is we're just going to start out with how do you find the derivative of the sine of x. So if f of x is equal to the sine of x, then you know that f prime of x is going to be equal to the limit as h goes to 0 of the sine of x plus h minus the sine of x all over h. Now, so in order to do this piece right here, what you have to do is you'll have to remember the sum and difference formula for that. Now, I'm just proving this, so the derivative is really easy and it's quick to memorize. I'm not going to make you prove it, but you should know where it comes from. So this is going to be equal to the limit as h goes to 0 of, well, the sum of the sine is going to be the sine of the first times the cosine of the second, plus the cosine of the first times the sine of the second, and I still have minus the sine of x all over h. So what happened is that green sum turned into this thing right here. Now this is going to be equal to the limit as h goes to 0 of, what I'm going to do is I'm going to kind of collect some like terms. I'm going to collect these I'm going to put together. See, is that right? Make sure. Sine minus 1. I have this by itself. Yes, okay, so this is going to be the sine of x times the cosine of h minus the sine of x plus the cosine of x times the sine of h. And this is all going to be over h, so this is all going to be over h. Now what I'm going to do is I'm going to pull these two pieces apart, so the limit as h goes to 0 of the sine of x times the cosine of h minus the sine of x all over h minus the cosine of x times the sine of h all over h. And remember that h is going to 0 here, so that means the sine of x, since there's no h here, the sine of x with respect to h is a constant. So I'm going to pull that sine of x out, and I'm going to have the limit as h goes to 0 of the cosine of h. When you pull out the sine, I'm going to have minus 1 all over h. And for this, I'm going to pull out the cosine function because h is only changing, so minus the limit, because the limit of the difference is the difference of the limit. So I'm going to pull out that cosine function, the cosine of x, and this is going to be the limit as h goes to 0 of the sine of h over h. Now these limits right here were given. We studied this one a lot. This one was discussed a little bit, but really we will prove these things a little bit later besides just using their graph. But this limit right here goes to 0, and this limit here goes to 1. So this is going to be the sine of x times 0, and this is going to be minus the cosine of x times 1, so times 1. So what we're going to get here is this is just, my bad, is it minus? Oh, that's a plus. That's a plus. That's a plus. So this is going to be plus, and this is going to be plus. So this is the cosine of x. So that means f prime of x is equal to the cosine of x. So there's a definition. What we're going to know is that the derivative of the sine is the cosine function. The derivative of the sine function is the cosine function. Now you can do something very, very similar for the cosine function as well. So the derivative with respect to x of the sine of x is equal to the cosine of x. Now you wish that they would be derivatives of each other. They're close, but they're not exactly right. So also we can say the derivative the derivative of the cosine function is the opposite of the sine function. Of the sine function. So it's negative. So what that means is that the derivative with respect to x of the cosine of x is equal to minus the sine of x. And what is nice about knowing the sine and cosine, their derivatives, now we can find the derivatives of everything. All 6 trig functions, because all of them are built with sines and cosines, and they're built with sines and cosines through through ratio expressions by division. So let's take some derivatives, get a little practice, and then we'll move on to find the derivatives of the rest of it. So example. Determine the derivatives. A. So if y is equal to x cubed minus the sine of x. So really this kind of comes down to memorization. I'm mixing some polynomials and with some trig functions. So what we know is y prime. Well, the derivative of this is going to be derivative with respect to x of x cubed minus the sine of x. So we're going to take the derivative of both these terms. So this is going to be 3x squared. And pulling out that negative, the derivative of the sine function is the cosine function. So really what we have here is the derivative of the sine is equal to the cosine, so that negative is still conserved. So just to kind of prove that to you, you know this is going to be the derivative with respect to x of x cubed minus the derivative with respect to x of the sine of x. So that's why this gives you a 3x squared, and this gives you minus this thing as the cosine of x. So when you take the derivative of the sine function, the coefficient in front does not change signs. But if you do it for the cosine function, it will. So B, if I ask for if I say y is equal to x squared times the cosine of x, well, when you take this derivative, what you know is that y prime is going to be the derivative with respect to x of x squared times the cosine of x. And really what we have here is this is an operation of addition and subtraction, so that's the way that works. But when you do operations of products, you have to use that product rule. So this is f times g. So a lot of times they're going to kind of ask you that, like, what's the operation? You're going to say product, and I'm going to say, well, what's the rule? And you're going to say product rule. So you know that its derivative is going to be equal to f prime g plus fg prime. So the derivative of x squared is 2x times g, which is the cosine of x, plus f, which is going to be x squared, times the derivative of the cosine, which you know is going to be the opposite of the sine function. So what we get here is 2x cosine of x minus x squared sine of x. Let's see. What about y is equal to the sine of x over the cosine of x? What if I try to take the derivative of that? Well, what we know is that this is of the form f divided by g. So it's a quotient. So we take its derivative, y prime is going to be equal to f prime g minus fg prime all over g squared. So the derivative of the quotient, since it's a quotient, what rule are you going to use? Well, you're going to use the quotient rule. So the top, the derivative of the sine. Well, the derivative of the sine function is the cosine function. Remember, the derivative of the sine is positive cosine, but the derivative of the cosine is negative sine, so we just have to be careful. Derivative of the top times the bottom minus the top times the derivative of the bottom. Well, the derivative of the cosine is negative sine of x. All over the bottom squared, so this is all over cosine of x squared. Now we clean it up. So the top is going to be equal to cosine times cosine is cosine squared of x. This is a negative, and this multiplies to be a negative, so this is plus sine squared of x all over cosine squared of x. And remember, in our pre-calc, that sine squared of x plus cosine squared of x is equal to 1. So this is 1 over the cosine squared of x, which is the same thing as 1 over the cosine of x squared, and 1 over the cosine is secant. So really this is the secant squared of x. So the derivatives of all the trig functions. Derivatives. I don't know if you noticed, I was just found the derivative of the tangent function. And that's how we do it. So what we know is that, remember that since we just did the derivative so we just did sine of x over the cosine of x, this technically is the tangent of x. So we've just found the derivative of the tangent of x, which is equal to the secant squared of x. So we know is the derivative with respect to x of the tangent of x is, so the way you do it, sine over cosine, and then just do the quotient rule, is equal to the secant squared of x. So you don't technically have to memorize these. If you want to find their derivatives, these things are all quotients, so you just use the quotient rule. And the only ones you really need to know how to do is the derivative of sine is cosine, the derivative of cosine is negative sine, with some identities. It would do you well to memorize them, I'm not gonna lie. Like, you're gonna get, it's so much quicker if you memorize these. So the derivative of the secant of x is going to be equal to the secant of x times the tangent of x. I'll prove this one next. The derivative of the cotangent of x, I would like you guys to prove this. I'll probably ask you to do it on the test or a quiz. It's going to be minus the cosecant squared of x. And the derivative of the cosecant of x is going to be equal to minus cosecant of x times the cotangent of x. So I'll prove this one, I'll prove this one. These two will be up to you, but they are almost identical to these two proofs here, okay? So the last one is, let's verify that the derivative with respect to x of the secant of x is equal to the secant of x times the tangent of x. Let me just verify that. So what I know is that this is going to be equal to the derivative with respect to x of 1 over the cosine of x so this is we have an f over g, so we have an f divided by g. So when we do this, this derivative is the derivative with respect to x of, so this is going to be equal to f prime g minus fg prime all over g squared. So the derivative of the top, the derivative of 1 is 0, times the bottom, which is the cosine of x, minus the top, which is 1, times the derivative of the cosine, which is minus sine of x, all over the bottom squared, cosine squared of x. So what we get here is we get, and that's just 0, so we get sine of x over the cosine squared of x. And remember what we're trying to do is we're trying to prove that it's secant tangent. So what I see here is I see a sine of x over cosine of x multiplied by another cosine of x. So this is the same thing as the sine of x over cosine of x times 1 over the cosine of x. So this is the tangent of x times the secant of x, or we can rewrite it as secant of x times tangent of x. So we'll move to a different spot in a second. Okay. If I'm bothering you, you can go across the hall. Okay. So find derivative. Take your time, okay? It's a challenge. They're all challenging usually. first test is always a little rough. So just take your time and work through it. Okay, so I'm going to take the derivative of this. So let's say this is a. So if s is equal to the sine of t over 1 minus the cosine of t, I know that this is a quotient. So it's going to be equal to f prime g minus f g prime all over g squared. So the derivative of the top is going to be equal to the cosine of t times the bottom, which is 1 minus the cosine of t, minus the top, which is the sine of t, times the derivative of the bottom. Well, the derivative of 1 is 0. Remember, the derivative of cosine is negative sine, so this negative is going to make negative sine, so it's going to be sine. Remember, the derivative of the cosine is going to change that coefficient sign, so that's why that becomes positive. All over the bottom squared, which is 1 minus cosine of t squared. Remember, you can't distribute. You have to FOIL if you wanted to, but just don't. It's better off to leave them that way. So what I'm going to do is, always the numerator we're going to simplify. So we're going to distribute and see if any like terms cancel. So this times this is cosine of t, this is minus cosine squared of t. And then I have minus sine squared of t. And I see something. Whenever I see sine squareds and cosine squareds, I'm thinking the number 1. But the problem is these things don't have the correct sign. If this was positive and this is positive, we would be good. That would become 1. But since they're both negative, I don't know if you can make that leap with me, but these things would simplify to negative 1 as opposed to positive 1. I'm going to kind of verify it. So cosine of t minus, I'm going to pull out a negative 1 from those, so this is going to become a cosine squared of t, and this is going to become a positive sine squared of t. So we factor in negative 1 from both of these, they become positive. And we know that those things are the same thing as 1, Pythagorean theorem. So what I have is cosine of t minus 1 all over 1 minus the cosine of t squared. Now, what we really would like to see is those things cancel, but they're not in the, they don't have the correct signs. Cosine of top is positive, cosine bottom is negative. The same thing with the 1s. The 1 is negative, the bottom is positive. But if I change the signs, I could factor out that negative 1 like I just did up here. So if I factor in negative 1, this cosine would be negative and that 1 would be positive. So I can rewrite it like this. And now we can see that that will cancel with one of those. So this is going to be equal to negative 1 over 1 minus the cosine of t. So we'll do a couple more just to feel comfortable. So let's say I'll do another one, and then we'll do a couple limits, and we'll be done with this section. It's not a very good one. So B, function p is going to be equal to 1 plus the cosecant of q times the cosine of q. So what we can see here is the operation between these two things is multiplication, so it's product, so we're going to use the product rule. So that means p prime is going to be equal to f prime g plus f g prime, or, that's f and that's g. So the derivative of the top, derivative of 1 is 0. Derivative of the cosecant. So a lot of times you guys are going to have to go back and take a look at these. I'm just going to show them to you, probably right on the next page, but we know it's the minus cosecant cotangent, but you guys are going to have to kind of, you're going to have these things memorized. So what I know is that we're here, aren't we? So the derivative of the cosecant's minus cosecant cotangent. So it really comes down to kind of memorizing these things. So this is something this will kind of help me. Notice the denominator of tangent is cosine, and the denominator of secant squared is cosine. Notice there's two of them down here. So cosine squared, remember it's a quotient rule, so the cosine here, this is clearly going to have a cosine squared on the bottom. So the derivative of tangent is secant squared. Now remember, this is 1 over cosine. It's funny that this easier function, 1 over cosine, becomes more complicated, but it is what it is. But remember, since the bottom is cosine, now I should have a cosine squared over here. Well, that is a denominator cosine, that has a denominator cosine, which gives you that cosine squared. Now, this one has a denominator of sine. This has a denominator of sine squared. This has denominator of sine squared. So it helps me memorize what functions go with what. They have to have that right denominator. So, back to here. Derivative of 1 is equal to 0. The derivative of the cosecant of q is going to be equal to minus the cosecant of q, minus the cosecant of q, times the cotangent of q. That's f prime. Times g, which is going to be the cosine of q. Plus f, which is going to be 1 plus the cosecant of q, times the derivative of g, which is minus the sine of q. And then we put these things together. So this is a product of three things. So, wow, that actually simplifies nicely. I'm going to turn these things into sines and cosines. Minus 1 over the sine of q. That's what this is. This is cosine of q over sine of q. And this is cosine of q over 1. I guess it doesn't simplify nicely, I was hoping. That's those three terms. I guess it's not that bad, right? Like, this is cotangent, right? And so is that. That's another cotangent. So this is actually negative the cotangent squared of q. That's what those things would turn into, because I got cosine squared over sine squared, but it's negative. And then over here, finishing this off, this times this is minus the sine of q. And then this times this is going to be minus the sine of q times the cosecant of q. Squish it in, I don't like it. So put it back over here. Sine of q. Now, the sine of q and cosecant of q, remember that this is minus the sine of q times, well, the cosecant is 1 over the sine of q. So these over here will cancel. These will cancel. So this just becomes minus 1. So this is going to be minus the cotangent squared of q minus the sine of q minus 1. So unfortunately this section is, you're going to practice your trig identities. It's just what it is. As we go through it, you'll get good at it. Trig limits. Funny they're putting it now instead of later. Okay, well, the one thing I want us to remember is remember that the limit as t goes to 0 of the sine of t over t is equal to 1. So just remember that. So A, what is the limit as t goes to 0 of the secant of the cosine of t plus pi times the tangent of, I don't know, I'll put this in this section, pi over 4 secant of t minus 1. I just want to make sure they still put this in there. They just get rid of it. No, they put them in there again. That's okay. So I just want you guys to have a heads up that you'll see them. All right. So really the very first thing we need to do is know if these things are defined. So things that we have to be careful of is denominators. Well, if I plug a 0 into here, this denominator, this is the secant of 0, which is 1 over the cosine of 0. And the cosine of 0 is equal to 1. So this is 1 over 1. So we're good. I can divide by 1. I'm fine there. So I'm plugging this thing in. It looks like I'm good here. This is the cosine of 0 as well, so this is equal to 1. Yeah, this is gonna be all right. So this is gonna be the secant. I think this entire function is defined at 0. Plus pi times the tangent of pi over 4 secant of 0 minus 1. So when we're done here, this is going to be equal to the secant of, well, the cosine of 0, that's just 1. Secant of 0 is 1 over 1, which is still 1. So this is going to be 1 plus pi times the tangent, well, that'll simplify to pi over 4, minus 1. Okay, these ones will cancel. That negative 1, that positive one's gone. So I have to know what the tangent of pi over 4 is. Well, tangent of pi over 4 is 1. So this is equal to the secant of the tangent of pi over 4, and this thing is equal to 1. So this is just going to be the secant of pi. Okay, now back to our unit circle. We know pi is right here, right? So this is negative 1 comma 0. So this is 1 over the cosine of pi. So it's 1 over negative 1, which is negative 1. So this is our answer. It's really just plugging it in and then using your unit circle to find their values. One more that I have to use that sine of t over t, and then I think that's what we have. Yeah, that'll be it. So the limit as t goes to 0 of the tangent of 1 minus the sine of t over t. So what we're going to use here is we're going to use the limit of the composition as the composition of the limits. What it means is if this tangent function is a continuous function over its restricted domains. So as long as we don't land on an asymptote here, which is like plus or minus pi over 2, or multiples of pi of those, then we're going to be fine. So I know that the limit of the tangent function is going to be the tangent of the limit. So I can really just plug the limit in here. Now the limit of the difference is the difference of the limits. So the limit of 1 is 1, and the limit of the sine of t over t is also 1. So the limit of a constant is 1. So this is going to be 1. The limit of this thing is also 1. So this ends up being the tangent of 0. And remember that I was worried about being an asymptote. It's not. It's not pi over 2 or negative pi over 2 or multiples of pi beyond those. So this is the tangent of 0, which is equal to 0. Because remember, it's the sine of 0 over the cosine of 0. And if you look at the unit circle here, that's 0. So this is going to be 1 comma 0. So the sine of 0 is 0, tangent cosine of 0 is 1, 0 over 1 is 0. And that's it. Yeah, it's not a very big section. It really comes down to this. So what you need to do is commit these four to memory. Well, actually commit these to memory and also the derivative of sine and cosine. So we know that this is going to become important. And the other thing was the sine and the cosine function. These things are important. So really what we just taught you is how to find derivatives of sine, cosine, and then also the resulting other trig functions. So these are the big ticket items here. Now memorizing these, and it's just memorizing these along with just using all the properties of derivatives, like what's the derivative of the sum of the derivatives. Derivative of the product has to use the product rule. Derivative of the quotient has to use the quotient rule. So really, you're basically just going to be practicing the previous section with these things, with these new derivatives included.